Hi everyone. So today we are going to be factoring by grouping. So this is the first video of a series of 3 that I will do concerning factoring by grouping. So I'm going to show you how to work these out. So let's go ahead and look at our first example. So for our first example, we have 10ab plus 15b plus 4a plus 6. Now, we have 4 different terms here. So the first thing I want to do is I want to look for a GCF, or a greatest common factor. I want to see if any of these terms, the coefficients can be divisible by the same number, or if they have any of them have all the same variables attached to them. This one does not have a GCF, but that should always be your first step. Ask yourself, does it have a GCF? And this one does not, because like 10, 4, and 6, like these 3, might have a GCF of 2, but 15 can't be divided by 2, for example. So we have to look at something that can go into all of them. So there is not a GCF. Okay, so let's go ahead and start the process of grouping them. So as you can see, we have 4, and factor by grouping works with 4 of them. So 1, 2, 3, 4. So what we're going to do is we are literally going to group them. So we're going to take this piece and write 10ab plus 15b here, and we are going to take this second piece and write 4a plus 6. Okay, so what we are essentially doing is that we are pulling these pieces apart, and we are going to be factoring each of them separately. Okay, and let's go ahead and get into it and see what it looks like. Okay, so we're just going to take these two because we've just grouped them. Group these two together, drawing in my ladder, and we're going to think of division. Let's look at our coefficients, 10 and 15. Do these two have a number that can divide into both of them? 10 and 15. 5 does. 5 can go into 10 and 15. So 10 divided by 5 is 2, and 15 divided by 5 is 3. So we know that one, okay? Now let's go ahead and look at the variables. So this one has an A right here. This one does not have an A, so we're going to leave it, okay? Let's go ahead and look at the next one. This one has a B, and this one has a B. They both have the B, so we can go ahead and pull out our B. Now let's start dividing. So 10 divided by 5 is 2. Now, we did not pull out the A, so we're just going to leave our A. And B divided by B is 1, so we don't have to write anything. Because remember, anything divided by itself, B divided by B equals 1. So we don't even have to write anything. Okay? Now let's go ahead and look at the next one. 15 divided by 5 is a positive, plus 3. And B divided by B divided by B is also 1. So we don't have to write anything. So we have 2a plus 3. Now, before we do anything, we're going to go ahead and look at this one now. So let's go ahead and look at our second group and draw our ladder. Is there a number that can divide evenly into 4 and 6? Both of them. 2 does. 2. Because 4 divided by 2 is 2, and 6 divided by 2 is 3. And let's look at our variables. So this one has an A. This one does not have an A, so we're going to leave this one. We can't pull it out because they both don't have it. So let's go ahead and let's look. Okay. So 4 divided by 2 is 2, and our A is going to remain because we're not pulling it out. Plus 6 divided by 2 is 3. And I'm looking at these two, and they match right here. So I see this piece right here and this piece right here, they match. So I know this is perfect. So let's go ahead and write our final answer. These two have to match. If they don't match, you need to go back and look at your work, okay? Because these two have to match. So when we write our final answer, we are going to be looking at, we're going to be combining this piece here and this piece here. So in parentheses, we're going to write 5b plus 2. So 5b, and then we pull out a positive 2, plus 2. And here, because they're the same, we only write it once, times 2a plus 3. And that's your answer. Let's go ahead and look at a second example. So for this example, I apologize, I'm moving the camera so these light reflections aren't showing up so you can see what the question is. It is x cubed plus 3x squared plus 2x plus 6. Okay, so we're going to start off, we're going to look for our GCF, our greatest common factor. Is there a number that can go into this, imaginary 1, 3, 2, and 6? No, there's not a GCF. So let's go ahead and get into it. We're going to go ahead and we're going to factor by grouping. So let's group them off. So we got this piece here. So we're going to write x cubed plus 3x squared. And let's go ahead and do our second grouping. 2x plus 6. Okay. Now, let's go ahead and factor these two pieces out. Okay. Drawing our ladder. What do these two have in common? So looking at our coefficients, we know there would be imaginary 1, but this one doesn't have it. So let's go ahead and get right into our x's, right? So we have an x cubed and we have an x squared. So we definitely know an x gets pulled out. Which is the one with the smallest exponent? 2. So we're going to go ahead and write x squared. So now let's go ahead and get dividing, okay? So x cubed divided by x squared. And remember, we subtract our exponents and we're taking out, two of the x's from this one. We're left with 3 minus 2 is going to be 1, so we have x. And remember, another way to look at this would be x to the third. We have x times x times x over x squared, x times x. And that would cancel here, and that would cancel here, leaving you with 1x. So that's another way of looking at that. Okay, and let's keep going. So we didn't do anything to our 3, so plus 3, and then x squared divided by x squared is 1, okay, because they cancel each other out. All right, we're done with this one. So now let's go ahead and look at this one here. Let's go ahead and factor this one. Now this one has 2 coefficients. Let's look at our coefficients and what we can pull out. So I see that there is a 2 and a 6. What number can go into both 2 and 6? 2. 2 can. Okay? Because 2 divided by 2 is 1 and 6 divided by 2 is 3. Okay? Now we're looking at our variables attached to it. This one has an x. This one does not. So we know we're going to be leaving our x alone. So let's go ahead and start our division process, okay? So 2 divided by 2 is 1, and we know that would cancel out, and we could even draw our imaginary 1, and we're going to put our x right here because we didn't do anything to it, plus 6 divided by 2 is 3. And as we can see here, looking at what's left over right here, our x plus 3 matches this x plus 3. Remember, this one would have an imaginary 1. We kind of put in our imaginary 1, but they are the same thing. And because these two match, they are great. So we're going to go ahead and take what we pulled out here and here, and we're going to write our final answer. So we have x squared plus 2 times, and because they're written twice, we only have to write it once, x plus 3, because they match, so we only have to write it once. And that is your final answer. Let's look at one more example. Okay, so we have y to the third plus 3y squared plus y plus 3. Okay, always look for your GCF. There is no GCF, so let's go ahead and start grouping. So I'm going to take this piece here and write y cubed plus 3y squared. And then I'm going to take this piece here and write y plus 3. All right, let's start factoring, drawing our ladder in. Okay, what do these both have in common? I see a y here and a y here, so we know it's going to be a y. Okay, this one doesn't have a coefficient. That's why I want us to start just kind of looking at this and going for it, okay? Because we know we would have the imaginary y. We looked at our coefficients, but we see that we've got a y and a y. Which one has the smallest exponent? Our 2. All right. So y cubed divided by y squared. We're going to have a y. And then we subtract exponents when we're dividing. 3 minus 2 is 1. So we would have had our imaginary 1 up here. Plus, we didn't do anything to our 3. We're going to leave our 3. Y squared divided by y squared cancels out. So we don't have to do anything. Okay? Let's look at this one. So, when I'm looking at these two, we have y plus 3. Is there anything they have in common? This one has a y. This one has a 3. I'm not seeing anything at all. So you know what I'm going to pull out? 1. I'm going to pull out our 1. Because 1 can divide by any of these. And you need to pull this one out, because when we match them, you know, 1 is a number. So you need to, if there's nothing you can do, you know, pulling out wise, like over here, pull out that 1. Okay? So now we're left with y plus 3, because y divided by 1 is y, 3 divided by 1 is 3. And look, these match. So let's go ahead and write our final answer. So I have a y squared here, and that 1 here, that's why it's so important to write it, because we need it. So y squared plus 1, y squared plus 1, that's where I'm getting it. And then we have these two that match, so we're going to say y plus 3.